the problem I decided to do is ratio of charges from electric field. So in this problem, it says a charge Q1 is located on the x-axis at x equals 2 meters, and a charge Q2 is located on the y-axis at y equals 6.2 meters. At the origin, these charges produce a total electric field that points at an angle of 31 degrees below the positive x-axis. What are the signs of Q1 and Q2? So what we can first do is draw a picture of this to have a visual. So we have our x-axis, our y-axis. We are given Q1 is right here. We'll say approximately, and this is 2 meters. And then on the y-axis we have Q2, which is at 6.2 meters. So in this example, we know that the x component of the net electric field is only caused by Q1, and the y component is caused only by Q2. So in this example, we have EX going this way, and then we have EY going that way. And then we have our total electric field going this way. We'll just call that E. And we know it's below the x-axis because theta was given to us. We'll call this theta, it's 31 degrees below the x-axis. So since the x component of the net electric field is only caused by Q1, we know that because the electric field has a positive x component and a negative y component away from Q2, we can conclude that Q1 is negative and Q2 is positive. So the answer is A. And in the next part, we are asked to calculate the absolute value of the ratio of charges, absolute value Q1 divided by Q2. So for this, we can find the x and y components using Coulomb's equation. So we have EX equals KQ1 over R squared, which gives us, K is always going to be the same. It's the constant. So we'll use 9 times 10 to the 9 times Q1 divided by our R given, which is x equals 2. So 2 squared. We can do the same for the y component. E of y equals, except since EY is going in the negative direction, this whole part is going to be negative. So we have KQ2 divided by R squared. And this will give us negative 9 times 10 to the 9 times Q2 divided by, we are given 6.2 squared. Now, in order to calculate the ratio, we need to use tangent theta equals EY over EX. And we know that inverse tangent of y over x gives us a direction. And we are given theta above, which is our 31. So what we can do is tangent of 31 degrees equals our y component divided by our x component. So we have negative 9 times 10 to the 9 times Q2 divided by 6.2 squared. Take this divided by our x component, which is 9 times 10 to the 9 times Q1 divided by 2 squared. What we can do is, since we're looking for the ratio Q1 over Q2, take our denominator, multiply it over. So that will give us Q1 divided by 2 squared, tangent of 31 degrees. And this will end up canceling out our K component when we move our denominator over to the left side. So that's why we don't have our K component anymore. Negative Q2 over 6.2 squared. So with this, we can do a little bit of algebra to get our Q1 over Q2. And this will give us negative 4 over 6.2 squared, tangent of 31 degrees. And this will give us a negative number because, as up here, as we've already established, our total electric field will be negative, but since the ratio has absolute value bars, the actual answer will end up being positive. So we get from this point negative 0.17318, take the absolute value, and that gives us, well, this gives us approximately 1.73 times 10 to the negative 1 as our final answer. And basically what we can do to check to see if this makes sense is that we know our final answer is supposed to be negative because, like I said before, the total electric field is going to be negative. So we know that this answer makes logical sense.